All right, what is up, everyone? Week 131 of building my own operating system. Thanks a lot for tuning in. As usual, quick sponsor message before we dive in. This is sponsored by myself, and I want to remind you that I'm looking to talk to people about their challenges in the world of systems programming. So if that's you, if you're trying to learn systems programming or go deeper into this world, I'd love to talk to you about whatever challenges you're having with that. I want to know how I can be most helpful to my audience. And so I would just invite you to contact me if that's something that sounds interesting to you. Technical questions, career, whatever. Here's my contact info. Yeah, feel free to get in touch. And without further ado, let's get into the stream. So this is actually pretty cool. We've made a lot of progress on the integration test framework we've been working on. And the chat is even working today. Apnobenzene, the first message in the chat. What is up? So early, yeah. You're first, actually. You get the award for being first one in the chat today. Which is cool because you get to get a sneak peek before everyone else shows up what's going on. I did a little bit of off-stream work this week. I used an agent to help me investigate doing some more work on the integration tests. And I found something really cool. There's this library called Snitch in C. It's a C++ library. It's a C++ testing framework. And the really cool thing about Snitch is that it is really lightweight and it's usable for freestanding applications such as an operating system type of programming. And so this is awesome because you can write very clean tests that look like this. And the reason why it's cool, like I've already had unit tests using Catch 2, which is this other framework, but Catch 2 is too heavyweight to really be viable to run in kernel mode. And so it's not usable for my integration tests. However, this thing actually is. So that's really exciting, and we'll go into it more in this stream about what it looks like to use a C++ testing framework in the kernel. Hello Code, what is up? Thanks for joining. Shout out to everyone joining the chat right now. Okay, Snitch. Yup. I think that is mostly it for the intro, so we're probably good to just get going. So Buffer Ghost in the Twitch chat. What's up, Buffer Ghost? Thanks for joining. I'm curious if we might get more Twitch people today because I'm streaming at a different time of week than I normally do. So maybe some different types of people can join. Doing well, how about you? I'm doing all right. Had a pretty busy week, but I'm looking forward to make a bit more progress on the OS right now, and yeah, keep moving forward on this integration testing stuff. Apnobenzene got the new job, physics faculty at local school. Crazy. Apnobenzene, the physics faculty. Like teaching physics, if I understand that correctly. Okay. Nicely done. So base 11. Hey bro, I want to ask a thing. C++ and programming things. Practice code daily. I am really interested in low levels. So I want to ask what path should I follow? A resource to learn. I got you. Got the resources page. It's not the most amazing resource, but it's a collection of resources I've collected on my website. So feel free to take a look at that. Okay, so let's talk a little bit about integration testing. So we've been on this journey to be able to write integration tests. The idea is that maybe that could be useful at some point. Up to this point, I have been manually testing my OS. I've been writing these random kernel tasks that do various things. The idea is that what if I could somehow run these things in a test suite instead of commenting in and out all this code every time I want to test anything? And that's the motivation behind having an integration test framework. The interesting thing is we're trying to do this in kernel mode because unlike the unit tests which run in user space on my dev machine as a normal program, with the integration test, the idea is that the system is fully integrated and functioning, which means it's really in kernel mode as very, very close to the actual setup for the production kernel. vpool, what is up? Nice to see you. And we made some good progress. So over the last couple weeks, we were first sketching out some of the foundations of how to even do integration testing. And the specific issue was, how do we actually launch we want to pass a command line argument to the kernel to select a test to run, but how do we actually invoke the kernel and pass a command line argument, because it's not so straightforward to do that because you need to build this OS image. And so the solution we implemented in probably week 129, I think, was to dynamically generate an OS image sort of just in time when you want to run a particular test. And there were some reasons why we decided on that design, and that works pretty well. And that's now the foundation for how we're going to build on top of this. And so maybe I can just quickly do a demo. Run test. And so we have this program called run test right now. And it tests.c++ integration test. So it's really basic right now, but well, just to orient everyone watching. So here's the main function of the kernel, and we get some kernel command line arguments from the bootloader. We parse them, we parse out this test argument, and here's where we branch. If we have a test argument, we run this separate boot path that's distinct from the normal kernel boot path. And that's where we go into this run integration tests function. Sup, Fearjod, what's the name of your software? Can you be more specific? You mean my OS or what software I'm using? It's VS Code. And for my OS, I don't actually have a name for the OS at this point. It's currently anonymous. Right, so now I can actually, so right now it's a little bit mixed up because I'm prototyping, but we have this page, we have this test called write to guard page false, write to guard page. And this tests that when we write to a guard page, it should page fault and panic the kernel. And so the idea is that I can run that test. And there's this other test. And so that's just the basic mechanics of this. Yes, Rust, then it's called offline OS. Maybe not. That might be in the running for the name, but it's not guaranteed. And so, yeah, so this is just demonstrating this basic infrastructure to run an integration test by dynamically generating a kernel image. What's up, Will Shepard? Have you thought about fuzzing? I have not really thought about fuzzing at all. To me, fuzzing is in even another level of advanced like testing to complement an existing set of unit tests and integration tests. And I'm still working on the basics, so haven't really gotten that far yet. There's also not really that much to fuzz in the OS because I've been focused on making all this test infrastructure. Anyway, so what happens under the hood in this here is that we are dynamically generating a kernel image, and we do that right here. We craft a limine config, and in particular, we patch in the command line to use, and we then create an ISO just for this unit test run, and we launch Kimu, and then we monitor the output for a couple sentinels like test passed or test failed. Yeah. What's up, user? When you build an OS, do you prefer monolithic kernel or microkernel? I'm going full on monolithic kernel right now, as monolithic as it gets. Yeah, I'm more focused on being able to experiment with kernel core constructs and primitives, and I'm a little bit less interested in like hyper stability of the kernel. So it also adds a lot of extra complexity to the kernel to make it a microkernel. What's up to MM Alam? Hello. Okay, so that's just me recapping some of the past weeks. So we have this primitive, this basic functionality to basically pass a command line argument to the kernel. And so now let's build up a step forward from that. So I think after getting this, we started looking into, last week was also involved with just actually writing, for example, this basic first test for writing to a guard page. And still not completely settled on that part, to be honest. Frankly, the implementation is kind of weird because for this set of test cases, unfortunately, the actual kernel production code needs to be changed. We actually need to inject a flag check into the production kernel code to pass the test. So that's not really beautiful. It remains to be seen if that's how we really want to do this. So now that in order to do this, because otherwise, in general, normally the kernel needs to panic if we write to the guard page. But under the unit test and only under the unit test, we actually want to trigger this test passed sentinel. So to me, that's a bit of an open question. The way I'm thinking about it is that there's different categories of testing, or like things I might want to test. So there's unit tests, integration tests, but even, and then like Will was saying, there's fuzz testing, which is even a different thing. And then even under the unit integration tests, I think there's two base like categories of tests. And there's categories that, I'll just call them normal integration tests, where success can be observed by the kernel itself. And then there's sort of, I don't know, maybe I'll call them termination, where as part of doing the test, the kernel actually terminates. And this second category feels harder to actually test. This first one is actually not so bad. I'll get to the questions in. Actually, no, I'll just yeah, let's check it out. Do you prefer testing your kernel on QEMU box or actual hardware? I am 100% QEMU oriented. No box and no actual hardware. Yeah, for what I'm interested in, there's really no reason to use hardware, and I'm just a bit more familiar with QEMU, and QEMU overall has a lot of nice features, and also supports different architectures in case I ever want to use a different architecture. It's open source. Can we contribute? Currently, it's just a private project for now, but maybe that will change in the future. We'll see. So just to show you an example of a more normal integration test, that's what I was getting into with all this stuff about Snitch, which is this library that I discovered recently. And so what you'll notice, for example, is that, so before I found out about this Snitch thing, as a reminder, Snitch is this framework. It's lightweight. It supports freestanding mode, which is a very unique and excellent feature. And it allows you to write beautiful unit tests in C++ that look like this. Basically, if you're writing C or C++, you're going to want to use some kind of test framework that provides test macros, which allow you to get nicer output when you run your tests. And so whether you write that test framework yourself, you're going to want some kind of macro framework, and it's its own project to do that. And my philosophy has been to use third-party dependencies when possible, and so that's why I'm using this. Before I discovered all that Snitch stuff, I was sort of doing things manually. And what you'll notice is that if you don't have the test framework, you just need to do a lot of things yourself. You need to be checking for string IDs and stuff. You need to be writing functions that correspond. You need to be dispatching from the string ID to the function. And so the test framework handles so much stuff for you, because it allows your tests to look like this. We use these test macros, and it takes care of features like automatic test registration, where you name your test and it automatically registers it with the test framework, which allows you to then execute your test either the whole suite or by name. And so it provides so much stuff for you. The test case, the registration macro, and then also these macros for checking and asserting that things are how they should look. So that's just me talking about why it's important to have a macro framework if you're doing testing in C or C++. And I have been working on integrating the Snitch framework for the integration tests. Let me just check in. FPS, what is up? I'm good, dude. Yeah, had a busy week, but yeah, doing all right. How about you? Yeah. Right, and so I was using a bit of the AI help to help me experiment with some of this stuff because it is actually kind of annoying. It can be cumbersome to integrate a third-party library like this, and so the way I do this is I vendor in the source code and I integrate it into my build system. Channel Nora, what's up? IT Gamer, what's up? What's the progress? What's up, guys? Yeah, going well. And so in today's stream, I want to move forward with this. And I think specifically the idea, so we have these classes of tests. We're just going to try to focus on getting this case working well. The termination tests, yeah, I think those are still TBD as to exactly how we want to handle them. Really, we only had one termination test so far, which was this general idea to try to write to a guard page and make sure that that faults. It's not the most urgent topic, and so it would be something that we can defer to later. And so I think the focus is just going to be on handling the normal case well. Yeah. Nice to meet you after 6 months. Oh, it's been that long. Crazy. Well, hope you've had a nice 6 months since joining the last stream. Yeah, we got a pretty full chat today. That's cool. All right. And so as a reminder, we have a couple types of tests. Yeah. They're sort of just all in this file. I'm just going to start out by, I think I'll just, yeah, I'll commit a few. This was a random. This looks like, for some reason, I get these random formatting. Issues. I think that was not. Okay. So, yeah. Okay. This was kind of random with figs memchar. Okay, that's kind of random. Let's see this this thing. Who is? Okay, it's 3 uses, so that's a separate commit. Increase size of stack for so snitch tests can run. Oh, Daxino, what's up? You know, I just dropped the idea to build the entire OS because it's such a headache. Oh man, you gave up your OS. Well, you can always pick it up again. Bro thinks he's Terry Davis. Who's Terry Davis? Yeah, who's Terry Davis? Yeah. Okay. Right, then there's all this infrastructure work to possibly do some unit testing. So All right. So I'm just going to commit some of this stuff so we don't lose it. Actually, it's time for the first 20-second break of the day. Feel free to join me for a stretch. Weird. Okay, so before we do a lot more crazy stuff, I'll just do a commit initial snitch work. Okay, so now we're in a safer place to keep working on stuff. But I think I'll just show you what I was experimenting with some AI support. And so there's this run snitch tests program, which will trigger the test framework and run all the integration tests. And that's what it looks like. And so the way it works is it actually runs all the tests in parallel. It does something to list out all the tests, and then it runs them all in parallel because it is kind of slow. Snitch tests. And so so with the snitch framework, you can, the tests register themselves, and the script triggers a run which lists all the tests. I can actually probably run it with a run tests. I wonder if this will work. It'll probably trigger a timeout, but maybe we'll see some output. Yeah, there we go. So if we pass this @list command line argument, then that triggers the framework to just print out all the tests, I believe. Yeah, anyway. Yeah, and so therefore the script can then parse that list. And yeah, and then grab the names of the tests and then run all the tests. So full disclosure that this script was AI assisted. Definitely. I do not know how to code bash that well with all this crazy sed stuff. So yeah. What's up, Yashov? I'm gonna hit you with the Rust command. Terry Davis created his own OS called Temple OS and created his own programming language called Holy C. That dude sounds crazy. That sounds like a crazy thing to do. Maybe it was a goat, I'm not sure. He knew who he was. Just maybe sarcastic, maybe. Yeah, I'm not trying to create a programming language. That sounds like too much. I like using programming languages. I'm not so into creating them. So Sakasham, what up? Okay. NSG in the house. What's up, NSG? Early stream. Yeah, I'm gonna go touch some grass this Sunday. So we're just streaming a bit earlier this week. Yeah, so let's make a little bit of a to-do list for today. Yeah, so we currently have this prototyped support for integration tests. which works kind of okay. Yeah, I'm trying to think about what exactly comes next. It is super messy. So let's just talk about all the problems. I mean, I think a lot of the I think most of the problems are code organization wise. So yeah, it's sort of a code organization between the framework and the actual tests. So VA80 in the chat. What is up, VA80? I see you, dude. Been a minute. Yeah, there's a lot to clean up here. The G test is there's like some new global state, which is not really that great. Okay, so the way this works actually is the kernel boots up. Just trace the control flow so I understand it. Kernel boots up, it goes into the into the test mode. And if we have, this is not really the final way it's gonna look, I think, but if we have Snitch in the test name, we're going to, we're going to run the Snitch tests. Question is, do you use Vim a lot? I use it sometimes. These days, I mean, I don't really use it for actual programming. I mostly use it for little stuff in the terminal and writing commit messages. The kernel boots up, goes into Snitch tests, and one thing that's interesting is the idea behind integration tests is for every integration test, the test wants to load a couple kind of custom tasks into the kernel and run them and ensure that, and yeah, these kernel tasks are going to be the things that actually exercise the kernel. So for example, what's the simplest version of this? The simplest version of this is like for our test for the sleep CPU cycles, where we have some code that reads the TSC, calls the sleep CPU cycles API, and then after that returns, it reads the TSC and verifies that the number of cycles is appropriately large based off of the amount slept for. So yeah. So Saksham, I test with Kimu. Yep, all with Kimu. The interesting thing here, I think we needed some other task that just keeps yielding or something like that. Let me go back to my tasks.hpp. Yeah, the always yield task. What's up with that? Do we have a version of that? I don't think we do actually, so I don't quite understand that part yet. But the main principle is like, okay, these tests want to load in some custom tasks which do some stuff. And in theory, they would call kernel.run, which is how, like, for example, that's how this works. This was the basic idea behind how to do an integration test. You pass in your test tasks into kernel.run, and then it's going to go and run that. The problem is that kernel.run never returns. It permanently launches into the scheduler, and that doesn't return ever. And so if we do it this way, that makes it impossible to actually run a different test, which makes it only ever possible to launch one integration test per execution. Maybe that's okay, but if we're using a test framework, it's sort of nice to be able to launch one run and launch a bunch of tests. And that's what the Snitch thing offers. And so if we just run it with no arguments, actually, never mind. This is a bit of a different case. This actually still is launching them all in one. But yeah, so the problem is that the run never returns. And so if we ever wanted to have a case where we boot the kernel and then it runs all the integration tests, we would actually need to not do it this way, but actually move things into a real Snitch task, like a kernel, have a kernel task that is sort of driving the framework. And that's what we have here with the Snitch runner task. And so at the very end of Snitch run tests, it launches the kernel with a single task. And that's the task that's going to call into the test framework to run things actually. And then so now from this point on, from now we're actually really in a kernel task. Before in this code, the kernel actually hasn't started yet. It's in that pre-kernel kind of boot phase. And then everything from here on is operating really in a kernel task. And then when we call into the framework, all of these tests, all the test code here is actually running in the context of a kernel task. And so that brings up some problems. And so we can see that everything here is using the G kernel, first of all, which is kind of interesting. Ordinarily, I avoid using the G kernel symbol because I'm trying to avoid using global state. And that's why tasks receive a reference to the kernel so that they don't have to use a global state. But the problem is, I don't know if there's a way to pass data into a test, because I don't really think that's how that works. So that's problem number one. Tests. First of all, test must use the G kernel symbol because there is no way to pass an argument to a test macro, ? question mark. I might just quickly spawn the AI in a snitch test.cpp. Tests use the G kernel symbol. Is there no way to pass an argument into these test macros? Okay, I'll have it research that. It's kind of, wow, it's pretty warm. I'm gonna turn a fan on. Give me 1 second. Gonna get the auto mode going. So that's one problem. Maybe there's no way to work around that. So that just might be a downside that the integration tests have to live with, but maybe that's acceptable. Yeah. Okay. What it buys you is this thing. Interesting. So with this fixture, that is how you can pass some context to a test. Honestly, I'll take it. This looks, yeah, I'll take this. I'd rather have this than all these tests using the G kernel symbol directly. So I'm gonna have the agent assist us with that. Great. Please port the tests to use this. The point is to reduce references to the G kernel symbol as much as possible. Okay. So that's pretty cool. So we have so we can have a kernel fixture, which is what sort of wraps over the G kernel reference. Yep. All right, 33 people in the chat. Very cool. It's a good chat day today. Let's check the chat. Javid, I'm from New York. Oh, word, what's up? Tuning in from New York, that's cool. I lived in New York for a couple of years. Yeah. Hey, you go to thank you. Arts. Got a lot of people. Yeah, it's VA80's back in the chat. So people be showing up. Kakashi Uchiha in the chat. Yo. Kakashi Uchiha. Well, guys, what is HPP? HPP. It's the extension I use for a C++ header file. I live in Europe, but I'm from the US originally. Oh, crazy big chat window now. Okay. How is it to learn OS dev? So Heil, great way, that's impressive, thank you. How is it to learn OS dev? It's not easy, but it's rewarding, and I like it a lot. Personally, it's one of my favorite, you know, it's a super fun topic for me. I'm very curious about it. I wish I had more time to learn it, but I do what I can. Yeah. Oh yeah, there's no name for the OS currently. What's up, Paradox Gamer? Okay, cool. Okay, so they got the 20-second break timer. Be right back. Okay. So how, yeah, for sure. The resources. There's some books in there. Yep. I have OS set 5th semester uni. Got you. Okay, so let's check out. So this was a pretty mechanical change. Yep, cool. So now let's check out how the tests look. So now all the tests need to use test case method. Interesting. So, yeah. We could even introduce another, like a macro called kernel test case or something like this. Like, that would sort of be some magic that provides this kernel thing, but I don't know if that's necessary. So in general, we just have this kernel fixture. It's a little bit of noise, bit of boilerplate everywhere, but yeah. Yeah. All right, I'm going to lock in for a little bit and then I'll get to the questions in a couple minutes so I can make a bit more progress. So, yeah. Sensei, what is up, Sensei? Nice to see you. Thanks for popping into this Friday stream. Right. Okay, so this has been fixed. Fixed with the fixture feature to mask the global symbol usage. Okay, so that was one problem. Nice that that's out of the way. What else? What else is in the way? So one thing I'm not saying, this function doesn't need to be a integration test. I think I actually already prototyped it actually. So this is really where it should be in a unit test, because this function is so simple and is pure logic, and so it doesn't involve hardware or anything, and so it doesn't need to be in an integration test. Let me just peep the Git history though. When did that happen? So that no. Maybe here. I think that happened here. Yes. Okay. So that means we can actually delete this whole thing. This doesn't need to be here. So Yatin, me finding printf. Okay, let's keep cleaning this up. I'll do a quick use fixture, quick progress commit. Okay, so now when we want to write a test, we just do one of these things. It's method with the name and I guess some tags, you can use them. Okay, let's talk about this. Again, I'm on this quest to not use global variables. So the problem is this test uses a global variable. This test is called the task wait for exit. And the whole idea is it's testing this API called task wait for exit, which a task can use to wait for another task to exit. And so I actually want to quickly check one thing. Right, so if I want to run a single test, I think I do this, oops. Sorry, my copy and paste has been sort of weird lately. Right, so that's me. Interestingly, I got a warning, but that's me running this task wait for exit test, which is running this code. Just for example, we can break this. Yeah, just to see what things happen. So if I just put a check false here, let's just see what happens. Do we see we see a test failed, right? And this is saying failed on task wait for exit. We get all this output, failed running test case task wait for exit at blah 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 96 check false. So that's what it looks like when test fails, for example. And so, of course, we're passing the test right now. And the idea, though, is to find some way to remove some of this global state. And I think that's actually the idea behind the fixture. So actually, no. The fixture is a setup that goes into a test case, which then the test case can use. This global state is set in this other task called the no-op-child task to indicate that it ran as an observable side effect. So the fixture is not what we want here. What we want is some kind of state that can be observed here. And I think we have a couple options for this. So as usual, I will list out the options. So problem using a global variable in this integration test to observe whether another task successfully ran. Let's see. I mean, strictly speaking, I mean, if we get to here, that means that this thing returned, but it doesn't necessarily mean that this other task exited, and that was the condition we wanted to test for. We wanted to, because you could imagine, what if we just, like, what if we actually just didn't have this test? What if we were just like, okay, let's create this other task, we'll wait for it to exit, and then it returned, and so at least we didn't hang forever. But that's not going to be a complete test, because what if there was some random bug that, like, what if there was some random bug where actually this function just immediately returned? So that would be an interesting test. So let's say we have this. So in the current version of the test, it is passing. And then just to illustrate the point, let's inject a bug. Let's just completely break this API where it no longer does anything that it should, it just returns. That means that this thing is going to return immediately, but this child task will, the no-op child task will actually never get a chance to execute, and so the actual behavior is broken. What we should see is actually this test should fail now, because the child task never gets to execute and set this boolean to true. So this is going to be false. Let's just observe that in action just to get some more practice with the integration test framework. Yeah, so now we can see the test, the test suite fails. Check G test got false, and yeah, I don't know what happens when I click that, but maybe it jumps here. But yeah, so that's just showing the power of having a test suite. And so especially that was just demonstrating what a failure would look like if we actually had one. Of course, that was a pretty stupid bug, but you could imagine other kinds of bugs. Maybe a bug in the scheduler for some reason doesn't execute this task or something. So yeah. All right, chat is popping off. Let's check in on the chat. How you all doing? Let me go to people who asked questions earlier. How to learn OS dev, like most tutorials are just theory without real implementation details. So my recommendation has always been to self-study some free university coursework. There's a lot of courses out there. Like for me, the first year of streaming was actually doing this MIT course. And so that was very helpful for me. Why are you building your OS? Is it just to level up, make it commercial? Resources? For me, it's a personal learning kind of thing. It's always been a dream of mine. I find it super interesting, and I'm personally motivated to do it with C++ using these third-party libraries. It currently has no name. What is the name of your OS? Currently has no name, but maybe it'll get a name later once it is big enough to deserve it. What's up, Akito? Holy, what is going on? What's up, Mart, Xer? Not a tech, not a coder, not a native English speaker. Just listen, don't understand nothing. Have a nice stream, brother. Thank you, Obo. Scrolling is messed up. What's up, Jerbear? I'm getting better at coding. How did you know what was clean code versus spaghetti? As someone learning on my own, I have no idea what to look up to for providing a feedback loop. That's a good question. That's a good question. I think this comes over time. As you write more code and as you take projects and work on them for longer and longer periods of time and try to build them up in size and complexity, I think you'll naturally run into issues where you've coded yourself into a corner in certain ways that makes it hard to extend the code in the future, or hard to develop the code without adding extra new bugs. And I think that's something that just comes with experience. As you write poorly designed code that's hard to work with in the future, and then try to learn things, yeah, and then learn how to do it differently with that experience. But I know what you mean. Yeah. I mean, yeah, feel free to join the Discord. I can try to provide some help around that if you want. I don't know who that person is. Feel free to, I don't know, tell us more. Why is this thing keep popping up? We're in Python. I'm trying to let me start tech. So Kalwa. Big 26. What's up, Newton Fish? What could differentiate OS from other OSs? It's gonna have similarities with Linux. Probably not. I'm not really interested in Linux or POSIX compatibility. I think for me, the differentiating factors are mostly about the implementation. I'm using C++. I'm using third-party libraries. I'm doing it in the real-time style. I'm doing it kernel mode only for now. So yeah, so DJ Kamar. Makes sense to work on a CLI game right now. C++. Your constant refactors, ceramic classes. So yeah, so you're getting a bit of experience already. You're seeing that you had to refactor something. And so you already have some intuition around what spaghetti code is just by doing that. And that just develops more with time. It's Digitalized. What's up, Digitalized? Stream popping off. Yeah, what's going on? We got 75 people in the chat. That's crazy. I'm new here. I want to be your first user. Like that was. Okay, thank you, DJ Kumar. Appreciate it. I apologize. Oh, shit. Dang. Sorry about that. Why not choose C? Do I have a... That chat is really popping off today. Do I have a C++ command? I don't even know if I do. Yeah, I mean, I use C++ because I just know it better. All right, guys, I need to get back to work in a little bit. So, but yeah, hope you're doing well, Digitalized. Yeah, hope everything's going all right. That's crazy. Okay. So Jerber, I do stream to Twitch. Like, I am streaming right now to Twitch, in fact. But no one really joins on Twitch for some reason. No one really joins on Twitch. I'm literally live right this moment on Twitch. So, yeah. All right. Chat's popping off. Moom. Yeah. It's all on my YouTube channel, Miguel. Okay, crazy. I need to get... Okay, let's lock in, guys. Chat is popping off. And I love it when that happens, but it also means we don't actually do anything. Except crazy. Whoa, Miguel with the donation. Well, okay, gotta say thank you very much for that, Miguel. And you get to go on the board for today. Go up here. I mean, if you want to see the series, it's just all on my YouTube channel. So you should be able to find it in my yeah, just like my playlists. Also the live tab has everything. So it's all there. Yeah. Crazy stream today. All right, let's just take a moment to like get back into some work. So right, the whole idea is we're trying to get the kernel integration tests going, and I'm thinking about how I can remove the global states. We just tested that it's actually needed to have this bool here. We want to have some kind of observable artifact that the test ran. And that is an interesting question. It's sort of like, ideally, we would be able to have some bool here that this thing can know about. This task can know about and flip to true. So we have a couple options. So the first option, use a global variable, which I don't love. Maybe it is the best of the options. Add a bool to the kernel. Oh, okay. Well, all right. It's the break timer. Feel free to join me for a 20-second stretch. Right. Yeah, chat popped off like crazy today. Wow. Yeah, I'm gonna get to the chat in a little bit. Crystal Players, man, I'm here. What's up, Crystal Players in the Twitch chat? Good to see you. Okay, so just to brainstorm, another option is we can move this bool somewhere different, somewhere into the kernel itself. So then the kernel can just do like kernel.child task ran. But that's also not really a great option because it sort of bloats the actual kernel with this test state. So that's not amazing either. So one thing that would be kind of interesting, it's not necessarily the best, but we technically have this pointer to the child task. Like, what if, you know, we could imagine something like this, where we actually check the child's state after this thing, which in theory is kind of a cool idea. The problem is that the child is destroyed after it exits. So it's not really safe to use that object anymore, because when a task goes through the exit, what does the flow work? P task to be cleaned up, that which goes into yield impl, which then is passed to switch to task, which then gets passed into destroy task, which then erases that task from the linked list, which calls the destructor on the object to node, right? Destroy data node, which does this thing. And so the question is, okay, that is kind of unfortunate. In theory, it's not sound. So option number 3, just to brainstorm, it's like use the P child task and check its state after the call. Sketchy, because the task exited and was destroyed. However, even though the object was destroyed, all that means is that the destructor was called on the object. And if we actually look at the task destructor, we'll see that there is no destructor. There's only the implicitly defined destructor, which is going to pretty much just call the destructors of all the members. All we really care about is this scheduler state thing. And in practice, I actually think it would work. I think there's nothing, in other words, there's nothing that's going to overwrite that field. The destructor doesn't overwrite all the fields. It just makes sure to call any necessary destructors for members that actually have destructors. But in this case, this task scheduler state is an enum. And so it's not a complex object with a destructor to call. And so I would actually believe that this would actually work in practice. We can even try it. We can even try what it looks like. I think it's going to pass. Yeah, it's going to pass. So we literally ran this code just now. Like when I ran the test, it ran this code which accessed the destroyed child, and the scheduler state matched exited. And so the test didn't fail. And so what happens there is that we are actually accessing memory that has been freed. So strictly speaking, it's like a use after free. Technically speaking, it's not guaranteed what the state of this object will. I mean, maybe it even is guaranteed that the state of the object will be there, but in principle, we're accessing a freed object, and so it may or may not still be in this this state where we can read the scheduler state. So yeah, chat is going off. Chat's popping off. I'm gonna not focus on the chat so I can try to keep working a little bit. So just to work through this idea a little bit longer. So we've just eliminated, I mean, I'm sort of eliminating that as a realistic option. Yeah, accessing a destroyed object is not really something I'd like to do if I can help it. And I might even be willing to use a global variable if it, yeah, over that option. I think one thing that is sort of obscuring this decision is the fact that these test, like everything is in one file currently, which is quite messy. So it obscures what is the framework and like what's actually the integration test. And the reason that's important is it's really, in order to evaluate how good or bad this global variable is, we sort of need to see it in a clear context. Because really there's really only three pieces to this integration test. There's the global variable, there's this helper child task, and then there's the actual integration test itself. And so if we were to see these all just in their own test file, it's a bit more clear that this global variable, it's only used in these places, and it's very clear the extent of the global variable. And so because the use is so minimal, it might be justified to actually use it. I'm going to ask the AI for some help to do that cleanup, and let's just see. So let's talk to the AI. So right, no. Snitch is messy currently and mixes up the test framework with the actual tests themselves. Please organize into one CPP file for the test framework components. And then let's take a look at so the actual integration tests, they're pretty much all testing some various scheduler stuff. And so these two are testing these two scheduler APIs. This one is testing this niche detail about the context switch. And so I'm going to, and so I'll say, please move the 3 integration tests into test scheduler integration.cpp. And then that will help us see it a bit more clearly. Okay, while it's going, let's check the chat. Right. What's up, Alanium? What's up, Good Cheeseburger? Real Kairos. New here. I want to be your first user. I want to try the OS for anyone else. I'm flattered. Well, stick around. Feel free to smash the subscribe or join the Discord. And I'm sure I'll be announcing it everywhere when the OS comes out. Alanium. I'll start recommending. Glad to find you. To the class on OS. What are some of the architectural choices you've made? It's monolithic, C++, real-time OS style, no dynamic memory allocation, high focus on unit testability, high focus on third-party libraries. Yeah, I would say a lot of the design is a bit more on the implementation side than it is on the actual kernel design at this point. Skill issue. Can't handle how based C and C++ are a skill issue. Yeah, YouTube has all the good, the based developers. So disable GOS. We're working on integration tests. Build BG1. My college is gonna start. Thinking to start with C++ as my first language. Any advice? I would not recommend C++ as your first language. I would really not recommend that. If you've never done programming before, I don't think C++ is an appropriate language to start with. It's just there's just too many sharp edges and ways to shoot yourself in the foot. There's too many pain points. I would start with Python if I were starting out. If I were recommending how to start out. Are you using any LLM? Yes, sir. I use Claude a lot. I also use Codex sometimes. People weighing in on the C and C++ thing. I don't use any manual like Vector. I build everything in C. You're German? What's up, Fan Vuong? I'm not German, although I live in a German-speaking country. No Indian, no guy. If you're asking me, I don't know. Yeah. Don't go to Rust. Where can I find this OS? It is private for the moment, so there's no Git info. Xenon edits, yo, what's up? Joey, making your own kernel, yes. Yeah, just doing some kernel programming. Wow, chat is popping off. So I am not equipped to answer that question. I think both. It's probably both. Personally, I've gotten so much smarter since AI came out. I talk to it all the time and learn about stuff. Turkic background? Actually, no. But cheers, thanks for the question. Are you on a quest to kill a global variable? Yes, Sensei knows. Sensei knows we are absolutely on the quest to kill a global variable. You know that all the stuff you're going to write is going to be absolute like tomorrow. It's like you're going to oblivion, but you're going there. Anyway, whoa, wall markets, you're going deep. I do not understand the sentence. What's up, Darko? Is Java a good language to start? Are we doing some Python? I don't know. I don't have a lot of Java experience. Yeah, my experience is more in Python, C, C++, Rust, that type of world. I don't really know if I would recommend Java to start. I have to say I wouldn't. I think there are better languages. Python, Go, Rust. What's up, Create with Vision? What's up, Prodcast? With the thing you're doing, building your OS? Thank you, man. Appreciate it. Trying to become advanced in C++. Was thinking about drilling OOP concepts. What do you think this will help? I think it depends on the job you're applying for. I think some jobs are a lot more OOP heavy than other jobs. I think having a good understanding of OOP is important. It is a core part of at least how C++ is designed, at least originally. And so you should definitely know virtual functions. But I think I would focus more on fundamentals like move semantics, object lifetime, containers, stuff like that. What's your general approach for using LM? I use it in a very controlled way. I understand everything it's doing. I prompt it at a very fine-grained level and review everything always. So yeah. What's up, June 1? What is this, warp? This is ghosty. I've tried Scala. No, actually, I've heard. I've never really been in the JVM world. I know there's like Java, Scala, Kotlin, and stuff. I've heard people like it. I never tried it. Just creating the UI of my own OS. That's my journey. You seem far ahead. It's funny. I don't have an OS. I don't plan to have one for a long time. I'm working on core system fundamentals right now. Because I think, to me, the UI is the least interesting part of the OS. It's like, if you want to do UI work, just write a GUI application. You can write a desktop application, like desktop framework or whatever, but to me, the more interesting work is the kernel. The Git setup like that to review more agentic view. Oh no, this is just like tmux. I'm just running tmux with some stuff like lazy git tools. Anyway, okay, cool. Back to coding. Yeah. So let's check out what the agent did. I have to go in like half an hour. So let's try to get some more progress done. So my prompt was just asking it to reorganize things a bit more so we can see things more clearly. So let's check out how things look. And so now if we look at snitchtests.cpp, we can see this file has a couple things. There's the entry point. There is the runner task, which is part of the framework. Halt forever is kind of interesting. That's sort of what panic is for. So I don't really think we need that, but whatever. Wire snitch output is very interesting. So this is a function that configures snitch to use the custom printing, yeah, for my OS. I even wonder if to do replace with log. Like, it's currently doing this kind of low-level thing and passing bytes directly to the logging sink, which is pretty low level. In general, to log things in my OS, you just call the log function. So that's a to-do use panic. Okay, but otherwise, that's how this looks now. It's the infrastructure for the test framework. And then now we can go over here and see a cleaner view of the integration test. So check it out. That's how this looks now. It's a file that has these 3 test cases, each exercising some different part of some scheduler API. So yeah. Yeah, and the point of doing that was to get a better sense of how evil this global variable is. We can see that it's just used right here. So it's a global variable, but it's also hidden from other translation units. It has internal linkage. So that downgrades the evilness of this global variable. It's not like a global variable that's like used all over the place throughout the kernel, like all this sort of stuff. It's a global variable that's just used in this one particular test file just to support this one particular test. And it's used by this private kernel task. So to me, yeah, that really downgrades how evil it is. And I'm more willing to entertain it, basically. All right, 20-second stretch break. Feel free to join me. All right. So there's some other stuff to do here. So right now this kernel fixture is private to this test file, but in the future we're going to have more test files with integration tests. So we actually want to move this, I think, into something else. Let's see. Compiler support. Yes, that'll be my next prompt. We're going to move the kernel fixture. Please move the kernel fixture into its own header. It will be used by all future integration tests. Right, so that's actually going to move out a couple of these includes. We're no longer going to have this kernel include. It's unclear why we have Oh, the x86 include is for the read TSC. That's interesting. So, right, so now that's how this thing looks. So we have the kernel fixture. Right. And then we're including the snitch header for, yeah, this. It's a little bit annoying. Just have to wrap it like that, so. But yeah, that's approximately the shape, though. I heard downgrade of evil from you, Marcus, which is a curse statement. Downgrade of evil. Such a funny thing. Love kernel stuff too. Nice. Yeah, chat was popping off today. Okay, so this is coming closer into shape. I think I'll do one more prompt. Move please move snitch tests, the test files into a test subdirectory within kern for the fixture, integration, test, and snitch infrastructure. Thanks Digitalized for helping out with people pointing to some of the resources here. What's up, Oscar? Yeah, VS Code. So, Rajni, yeah, it's been about 2 years. Been a bit over 2 years of streaming. Yeah, but yeah, I only started on this OS maybe a year and a half. No, a year and like a little bit over a year ago, I guess. So, yeah. Okay, so now this is how our organization looks. So we have the kernel, and then there's this test directory. Some other stuff here, tests, right? Integration tests. Integration test files in test into in kern into that dir also. Right. Yep. So yes, now we got some more organization here, but really this is sort of the final form. But the AI forgot to remove an include, I think. Or did it? Wait. No, never mind. We still I forgot to remove this comment that we clearly still need the kernel include because we use it all over the place, but we're not, it's not only for the G kernel. I don't really love this. Yeah, these comments are not so useful. Like that one was particularly stupid. Yes, the task. We don't really need any of this. Probably support. Okay, this is way too verbose as usual. This is the interesting part. Okay, let's okay. But in general, this is how things are looking. Yep. Ray, Friday stream Unreal. Yes. Yes, I have some plans to touch grass on Sunday. So yeah, gotta do the stream at a different time. Okay. This is looking pretty good. So I think my conclusion is that I'm okay with this, like, quote unquote local global variable. Also, I don't know if it needs to be volatile. I don't think it needs to be volatile. So I would sort of like to, I mean, it's, yeah. These things only apply to this particular test. Maybe I will move this closer to the top. Wow. Just to make that clear. Just a little bit, move them a bit closer together so you can sort of all see this as one piece. Okay. P-Shop, man, we just read so we don't dereference it. Yep. That's one thing that's kind of tricky. It's like you need to know to, after you use this API, you need to know to not use this this thing anymore. So that's just a bit of a C++ thing. So we'll clean this up. This is weird. Check is not equal to null pointer. Oh, I see. That's related to this comment. Yeah. Wait, you're touching grass? Dude, there's this rumor out that I'm touching grass. Yeah. Camiono, hello, nice to see you. Thanks for popping in last time, and again. Programming stream with some of the people from Trail. Do you mean, what Trail? You mean Trail of Bits, or what are you talking about? Thanks, Mustafa. What's up, Kudaletsi Tea? Kuda Iced Tea. We're in the beginnings. We're not that far. But we have a bunch of infrastructure. That's pretty comfortable. Why do you choose C++ but not Rust? I've got you, fam. The Rust command. I just know it a lot better than I know Rust. Nah, just the, yeah, VS Code. Rajni. I've been programming for a long time, man, like over 10 years. I mean, probably more like 13 or 14 at this point, so yeah, I mean, this stuff is basically just the culmination of everything I've learned over my entire time programming. Max Broski, what's up? Buy your own OS. Yeah, just for fun, for learning, to see what it looks like to do it in C++. Use C instead. About to eat dinner. Back in a few. All right, enjoy your dinner. Opinion about vibe coding. I think there are appropriate times to vibe code. I think there's also dangers of vibe coding. So, as with any tool, you need to know how to. Yeah, it can be used as a weapon or a tool. So, yeah. All right, let's check out this one particular thing. So one of the One of the interesting things about using Snitch in the kernel, this Snitch test framework in the kernel, is this detail about require. So let's just let's make a little test case for experimentation. Require test. Can I do this? I wonder if I can do this. So we'll just clear out this whole thing. And I'm just going to put a require false. And so test frameworks sometimes expose the concept of a require versus a check. At least that's how Catch 2 does it. That's how Snitch does it. Checks are for when you want to check the condition of your test case. Yeah, like you want to check. It's just the most basic form of a check. The require is kind of similar to the check, but it's for preconditions. And so the key difference is that if a check fails, that doesn't completely stop the entire test from running. If a check fails, it'll keep going and run the other checks in the test, which allows you to do a single test run and then get multiple results back of like, okay, these things passed and these things failed. Whoa, I see the chat. We're at 71 people in the chat. That's crazy. I'm going to take a quick moment actually while we have 71 people in the chat. I'm going to just do a quick break to my sponsor message, which is me. So if you guys didn't know, so I'm trying to learn how I can be more helpful to all of you people who are my audience of systems programmers or people getting into the world of systems programming. And so I'd just like to invite you to contact me so I can talk with you about your challenges, whether they are technical challenges or career challenges or something else. Feel free to just hit me up. Here's my contact info. I'm on Discord, Instagram, or email. My contact info is in the description of this video. And so I'm just going to throw that out there. I would love to learn how I can be more helpful to you people. And so feel free to hit me up. All right. Add sponsor, read over. Okay. So yeah, let's talk about this. Some questions. Syed. Yeah, I got this sick integration testing framework for my kernel. Thank you, Dan. Sanjay, doing this for 2+ years. Yes, sir. Trail bits. Yeah, man. I know. I mean, it's been a while since I worked there, but I know some people there still. Be cool. You got motivated to choose the stuff to do. Man, I just think it's fun. I just really enjoy it. Main toolchain. I'm using the Clang LLVM toolchain. Need to build an OS in Python? Probably not. You guys in that crew know quite a bit about machines. A little bit. Doesn't matter. It does not Camiono weighing in. Does not matter which language. You just need to feel comfy. I wouldn't recommend SM only for OS dev. And what areas of the kernel are inappropriate for vibe coding? I mean, it really depends on how you're using the kernel and your needs. Like, if you're trying to make a production kernel that people are going to rely on, then I think almost no part of the kernel is appropriate. But if you're just playing around, then everything's appropriate for vibe coding. And so my personal point of view is, for me, what's appropriate is test infrastructure, scripts, like things that are not the core kernel. In the future, I think actually application code, I'm also fine to vibe code application code. But for me, where it crosses the line is core core kernel infrastructure. And so that's stuff that I want to do myself and have really strong understanding of it, and ideally code it all myself. So yeah. All right, Side. Yeah, nice. Totally hit me up. All right. So let's talk about the require. And so require is for preconditions, and the difference between require and check is that require stops the test. This is just for things that are like for just core conditions for the test to even be in a valid state. And so if a require fails, we just don't want to even try the test because something is just fundamentally wrong with the preconditions of the test setup. And so classically, we might use a require here, pchild, right? That's what I actually would expect to see here, because this is part of the test precondition, and then this is the actual thing we're really trying to test. We're really trying to test that this task resumes and gets code execution again, and then that this Boolean is true. But this thing is more just like, okay, for the test to even be valid, we need to have the create task function work and return us a child pointer. But the test wasn't doing that, and it was instead doing this weird check return thing. And to be clear, the AI was explaining this. Require would terminate and abort the whole suite. So we use check and manual return. Yeah, so this is problematic if we're trying to run an entire test suite. If a require fails, it calls stood terminate. That is actually interesting how that even works in user space. But let's just see this work. I think terminate. Yeah, so we have this custom terminate. In general, there's no stood terminate in my OS, but for the purposes of the integration tests, we actually define it. So let's try running it. So I'm going to go here and run the require test integration test. And we can see that it failed. Snitch called stood terminate, right? So that's what we expect. And furthermore, we can see that even if we run all of the snitch tests, right, in this case, it actually doesn't really matter because they all run separately. It's really only a problem if we were to ever try to just run all of the snitch tests in a single invocation, which I think is supported if I do. All right, coming to the end of time because I gotta go kind of soon. So right, so in my test runner, there are some custom right. Okay, so if I do run tests, run test, and I just do snitch, that's going to trigger we're going to go into here, we're going to go into this if statement, and it's going to trigger the test runner with an empty test ID, which runs the whole test suite in a single boot. And so just for educational purposes, let's just see that happen. Oh, wait, Snitch. Okay, interestingly, that only ran one test. I think, do I need to just pass nothing? So it's going to pass test equals snitch. It might be a formatting thing. Oh, sorry. I would have thought that this... Yeah, that executes all of the tests. If we do it like this. So what I'm trying to show, so sorry, just to be clear, we're running all of the integration tests in a single boot, right? So the OS boots up one time, it then goes into the test framework, and the test framework goes like, okay, run, all within a single boot. This is as opposed to this other script I have called run snitch tests, which actually launches every integration test in its own boot, which isolates them more from each other. So I'm still figuring out how I want to do this, but in this version, we're just running them all in a single boot, and we can see that in the output where it says all tests passed. And what I want to show is that, so that's currently working. If I include a require here, it's going to break this, I think, which should not typically happen, but the require here, it's going to trigger a terminate panic of the OS. And so we're not going to get to these other ones, I think. And so let's just see what happens if we include the require. I think we're gonna have a timeout potentially. Yeah. And so in this case, the require failed in like the first test, and it blocked the other tests from executing. And that's not something you typically want. Like, in general, you want your tests to be fairly isolated from each other. And so even if one test fails its require, you still want the other tests to be able to proceed and do their thing when the test suite runs. And that's why the code was doing, that's why the AI had prototyped this using a return, which is a little bit actually non-standard. I'm not even sure what really happens here. Because from this declaration, it's not really clear what this even is, if it's a function or whatever it is. And so as just an experiment, I don't even really know what's going to happen. Let's just see what happens if I just do a return here. So my expectation is that all of the tests should run now, but it's not clear to me that this test is going to pass. And I would actually hope that it fails. And so let's just try. Yeah, so that's interesting. It says all tests passed. 4 test cases, 6 assertions. So that actually means that this doesn't really work. Yeah, the AI was doing a check and return as a replacement for the require, but that's not correct because we actually want to show that this fails. If we're in a position where a require is going to fail, what was happening here is it just silently actually passed the test, I think. And so we don't want that. So we definitely don't want this from what I can see. I am not sure. I mean, for now, I think all we can do is just do a require. And so that has the downside of like tanking the entire test suite run if it ever fails. But that is kind of okay. And it prevents the rest of the test suite from running, and it prevents other issues from being uncovered, but you'll still need to fix this anyway. And so it's not the worst thing to have it tank the test suite. Even more so, like it's not a huge problem because I think in real life, I'm going to use this script that triggers a different Kima boot for every single integration test, which better isolates them from each other. And so in that case, it actually doesn't matter if one fails because that's at that level, like this require is not going to block the rest of them from running because they're triggered at in the orchestration script at a bit of a higher level. And so I think my takeaway is that it's actually okay to use requires in my integration tests. So I'm going to delete this comment. Yeah, so now this is looking pretty good. I'm actually pretty happy with this. We can delete this. I don't think we really need to. Yeah. So, yeah. Chat, what do you think? What's the vibe? Personally, I think this is looking pretty cool. And so it feels cool that now, again, to recap, one of the reasons I was doing this is because formerly, the way I was testing my kernel is I just have this random file called tasks.hpp with a bunch of random kernel tasks, which I would write, which exercise different parts of the kernel that I'm developing. And so when I'm using, when I was developing the task wait for exit API, I wrote some tests, like some tasks here that exercise that. My mouse is going crazy right now. When I was working on the task sleep CPU cycles API, I wrote some tests for that here. And I would just comment stuff in and out whenever I wanted to test these features. I would just comment like in these functions and just run the kernel. And that's so manual. It's so cumbersome. It's so messy. And so that was the motivation for trying to develop a in-kernel integration test suite where I can port all of those ad hoc functions I was writing into these functions in the test suite. And then now I don't need to like comment things in and out of like the main function of my kernel anymore. All these things just live here in the test suite and are separate from the actual production behavior that my kernel should have for real. And so it decouples the production code from the kernel, from the test code. Yo, Ismail, what is up? What is up? My mouse is going crazy. Let me check in on the chat. We've got a fire chat today. Yeah, I want to thank you all for popping in. Yep. Yep, not much to gain by writing assembly by hand. I would agree with how to about that. Teen artist tried making a tiny kernel, but I quit after a few lines because of the amount of knowledge needed to even start. You guys have any tips or advice? Digitalize pop in with the MIT recommendation, which is always a classic move. Personally, yeah, I think Digitalize did a different version of the course, but yeah, I think Digitalize and I both did this course, and it was quite helpful. It's also not really beginner. It's not the most beginner friendly. Like, you should have some other programming experience before you try that. But I totally empathize with this. There is a lot of knowledge needed, and a lot of people I think there's this impression that you can just go on the OS Dev wiki and follow some tutorials, and I would not recommend that approach, because I think for this topic, it's it's just complex enough where you benefit from having more structured learning materials, like AKA a course. So like an OS Lite. Not sure what you're talking about, but I would consider my OS an OS Lite. Yeah. MIT course not opening. Let's check it out. Yeah, I gotta always rep the venerable MIT 2018. And so what you gotta do is you just gotta go to all these labs. Yeah, you can't like get in to the private like MIT forum or whatever, but you can absolutely just do all the projects yourself. And in fact, that's what I did for the first year of streaming as the real OGs in this chat, like Ismail and Digitalized have seen. Do I use AI? Yes, definitely. Code, what's up? What's your mic setup? Using a Zoom H1N mic. It's just yeah, it's like it's a decent mic. I've had it for a long time. Works pretty well, I think. Cool. What's your current dev setup? Yeah, I mean, I run the OS in Kimu, and that's pretty much it. It's just this emulator. So, yep. Brave, thanks, Lewis. Why don't you use Rust for creating an OS? I don't know Rust. That is the reason. I'm from Pakistan. What's up, Mashal Khan? Evening, sir. Should I learn in college? I don't know what JEE is. So maybe you could provide some more context. So Ismail, you're coming in a little bit towards the end of the stream, but check out what we got working. So we have a in-kernel integration test framework working now. And so all this code that used to be in tasks at HPP, this sort of like ad hoc code, is all living in here now. So I have these dedicated places for a test suite. So what exactly am I testing? And so basically I've just ported all the ways I was previously manually testing the kernel. And so like a few weeks ago, we worked on this task wait for exit, which allows a task to block until another task finishes. And so this is just a test that this works. We worked on this sleep a few weeks ago. And so now we just got to test that this is working. And so let's just make this very satisfying. So now let's run the test suite. So we should see some passes. So So currently there's like basically 3 tests. And let's just do some stuff to make them fail and break. And just to show, like, let's pretend in a couple weeks I was working on the scheduler again and I injected a bug and I accidentally coded a bug in the scheduler and broke this function and just made it return. Now if we run the test suite, we should hope to be able to actually see a test failure. And check it out. We see this like loud message. It's like kind of hard to read the output. But we can see test failed, running test case task wait for exit. And so previously, before I had this framework, if I accidentally coded a bug, I would just need to like run my kernel and just see that like stuff is like broken, right? And then I'll be like, oh man, now I need to fix my kernel. But now I can just run my test suite. And so let's also do this in another place. Let's break the task sleep CPU cycles somehow. Like let's also just return. That's going to make this just return immediately, which is going to read the TSC like immediately, which is going to be a lot less than 10 million CPU cycles, I would think. So let's just try that again. And do we see it? Test failed. Running task sleep CPU cycles failed. 36,000 is less than 10,000. Okay, so Ismail, you're asking, is this catch 2? It's actually not. And that's both cool and also a bit unfortunate. I am using this test library called Snitch, which is a direct competitor to catch 2, but its thing is that it's lightweight. And in particular, it advertises itself as usable in freestanding environments, i.e. lacking an operating system. Right. Yeah. And so the thing is, Snitch is extremely similar to Catch 2. It implements basically the same API. Like it's so similar to use it. Like the macros are kind of similar. Like it's just a different implementation. In theory, I might even be able to port my unit tests, which use Catch 2, to use Snitch, which would allow me to unify on a single test library. But for now, I'm using 2 test libraries. It's Catch 2 for the unit tests, and then Snitch for the kernel integration tests. Yeah. So, okay, last thing we'll do today is we'll just break. This will be fun. Let's break the flags test. This is a very specific test, and I added it because I actually just had this bug in real life. In my context switch, in the first version that I wrote, I completely forgot about the flags. And I just did not do anything about them. I didn't save them or restore them. And I think someone only pointed it out to me on stream, actually. And so let's just try to test this. Let's what would be the best way to break this? The most minimal way to break this? I think the most obvious thing to do would just be to simply stop saving our flags. I mean, yeah, I guess the most minimal thing to do is to just stop saving and restoring them. And I think I might need to think a little bit more, but let me see. So the way this works is the test explicitly sets a particular flag with the std instruction, yields, and then when it resumes, it clear direction. It checks that df is still set after the round trip. So let's just see how, if that works or not. I'm hopeful that it should fail. And it even seemed like it actually passed. Wait, so let's just remove this. Okay. That is interesting. Okay, so something is kind of wrong here then. Or, or not, I wonder. There isn't really another task running, so it might be possible that the direction flag is just simply preserved accidentally somehow. But yeah, I don't know. I will need to read a bit more into this, and I think I just don't have the time. I do need to leave right now, but it's been an awesome stream, guys. I'm just gonna wrap up by quickly doing the self-promotion thing again. This stream is sponsored by myself, and my favor to ask you is I want to talk to you about your challenges in the world of systems programming. I want to learn how I can be more helpful to my audience of all you people that are interested in systems programming. And so feel free to just reach out to me on Discord, Instagram, or email if you have some challenges that you need help with. I would love to talk to them, talk with you about them, if they're technical or whatever. So I would just invite you to hit me up. All right, fam, that's gonna be it for today. We got this clean set of integration tests, and that's it for today. Let's wrap it up. Thanks a lot for joining, and I'll catch you next week. Peace. Bye.